A little bit different this year. Well, we did it over this past summer, and instead of the traditional school setting, we had a summer camp. And RIT runs a summer camp for women in engineering. It's girls, and they try to introduce them to engineering programs throughout the whole college and all the different programs. And what had happened is the end of 2011, I got the ARRL mailings, and they made an announcement that ARIS was going to be opening up the application process for schools to do this again and talk to the International Space Station. So, all right, well, we'd never done it at RIT before, and I thought about the summer camps that they have. So I approached the girl who runs the program, and she couldn't believe it. Didn't even think this was possible. So she's very excited. Let's do it. So we went online, got the application, and of course the application is, you're talking government here, or semi-government, NASA, so they got a million questions and they want to know if you qualify and everything else. We got through that application process, and we're thinking, well, let's see. Usually when this happens, you're fighting against 100 different schools, and what are your chances of getting picked? Well, we thought for a second, so well, this camp runs in the summer in July, and school's out pretty much everywhere else. So I had a pretty good chance. And sure as heck, we got a call from Johnson Space Center, and they want to know a couple more things, and they said, well, we'll let you know in a couple weeks. And almost a year ago today, they let us know, and they said, you're it. So we had an opportunity to do this, and this is what ended up happening. They were scheduling a flight coming up in July. We didn't know the exact dates of the availability. We had to tell them when our camps were, and we had to look at what their schedule was, and they don't really go out too far because a lot of things happen with scrub launches and all kinds of things that can happen with NASA. So they just kind of give you windows, and you hope for the best that it'll actually happen. And to cut it short, we ended up having 2 camps this past summer. The first one was too early. Didn't make the window for any of the active flights. And the second one, we caught it just in time for that to happen. So I'm going to talk just a little bit about the 2 programs and how they merged together and what we did to make this actually happen. So we have the astronauts here that went up, and in particular, I'm going to draw your attention to Suni Williams. They're hams. Everybody's a ham here. And we ended up talking with her. She expressed an interest right off the bat in being involved with the Women in Engineering. And what I didn't know when we started looking at this whole process was that there are, I think, to date, approximately 60 women astronauts that have gone into space. So I didn't realize there were that many women involved in this in the space program. They were actually flying. So they really got the Women in Engineering program excited that we're going to do this. And the space program, this particular one, this past summer, represented 20 school districts, including homeschoolers and 3 private schools. And the theme, ironically, just turned out to be this way. It was called World in Motion. So everything worked perfect as far as the theme for the space program and what they were doing. And they said this couldn't be any better. The timing just worked out perfect. I had to have, unfortunately, a lot of people to make this happen. We had a problem early on. We knew this was going to be a situation. We're probably going to have close to 100 people involved in viewing this. And I don't know if anybody's been to Xerox Auditorium at RIT. We had no way of getting radios into Xerox Auditorium. And schools who can't even get hams involved at the school, a ham somewhere else in the world will make this contact for them. However, we said we'll just do it locally. So I ended up having about 1, 2, 3, 4, I think about 10 people involved in this. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13 people involved in making this happen. We had myself and 5 other hams from pretty much students at RIT. And we ended up, I had to bring in some people. I brought in Frank Sharam and his wife and Jen just to cover some things we didn't have enough people on hand to do because this was in the summer and RIT was not in session. So It's running with a skeleton crew. And I had some RIT staff that was involved in video production. I had another sys engineer running Skype, and I had an audio engineer who was actually a professional audio engineer. We have on staff, and he helped us with some of the audio mixing. So I'll go ahead and next slide there, Frank. So I'm going to show you how we bring this all together. Just a quick background on the WE program. It's called Women in Engineering at RIT. It was founded in 2003. And it's dedicated to increasing the representation of women engineers and women leaders in the engineering profession. And in the past year, we at RIT has hosted over 20 programs. This is just in 1 year on average. 20 programs that support the organizational mission of increasing the representation of women engineers and leaders in the engineering profession. And currently, over 2,000 K through 16 students, parents, and educators have reached through this program. So it is a very successful program since 2003. They also offer programs for prospective, incoming, and current women engineers students, including a retreat. And the results are very impressive. It says over the last 5 years, the number of women entering our education programs has more than doubled. So it's a very, very successful program, and we're glad to have it on board. Just a quick overview of their program. It's outreach, designed for girls and young women, grades 5 through 9. The camps for grades 5 through 9 are a week-long program, so this is what was involved in this particular operation. They have some noteworthy accomplishments, and I just won't get too specific here because I don't want to tie this whole thing up. Go ahead to the next slide there, Frank. And some of the lessons and objectives, they cover a wide variety of topics, including various engineering disciplines, including electrical engineering, which is the department where I work, and mechanical, computer, biomedical, and industrial system engineering. And we're expanding it also into chemical engineering this year. And the objective is a hands-on engineering experience through team projects, classroom knowledge, RIT engineering lab experience. We take them right into our labs. Design activities, we have guest speakers and tours. And they gain leadership skills through the camp activities and instructional staff. And they do have fun with team building, recreation activities, and the engineering themes. They meet a lot of friends, and they share interest in the math, science, and engineering. And it's very, it works quite well. We're very happy with the results we've had. Go ahead, Frank. So that's a little background on the Women in Engineering piece. I want to bring this together eventually, so I'm going to give you a little background on amateur radio on the International Space Station program. Next slide. It's a cooperative venture of NASA, the American Radio Relay League, ARRL, and AMSAT, which is the Amateur Radio Satellite Corporation, and other worldwide amateur radio groups and international space agencies. And the goals are inspiring an interest in science, technology, engineering, and mathematics, or the STEM subjects. It's particularly aimed at young people. And they provide an educational opportunity for students, teachers, and the general public to learn about space exploration, the technologies, and amateur radio communications. And they provide resources to wireless technology and amateur radio to assist teachers who teach STEM subjects, and we're providing an opportunity for amateur radio experimentation and evaluation of new technologies. That's an overview of the program. So available to us for this particular window were 2 scheduled launches. Expedition 3132 and 3334. So we were able to do Expedition 32, and there's a snapshot of the team that went up during that window. And when I tell you it takes a team to do this, it really does. From my previous experiences, I learned a lot. Pete Fornia brought me through 2 different contacts through different schools in the area, Webster and Henrietta. And it has to work perfectly because you only have one chance. You don't get a second chance, all right? And there's a lot of preparation that goes in to this on the school end for the students because they do have a program that they go through to prep for this contact. So when this thing happens, you don't get a second chance. So it really has to happen. So when I say it takes a team, technology, responsible for their radio equipment and our PA setup for the day of the event. Education, responsible for developing an educational plan and making that plan available to educators and students. There's an assessment evaluation and responsible for ensuring the completion of NASA surveys, ARIS activity reports, and the ARRL survey. and media. We're responsible for drafting the media advisory and promotional effort. So this is pretty much how these contacts work. There's a timeline that they set, and it goes out. Obviously, we had about 6 months to prepare on this, but really nothing happens until, I mean, there's obviously the academic portion, the teachers are doing their piece of it, but as 6 weeks start to roll out, 6 to 8 weeks start to roll out coming up to this contact, we really have to start getting our act together. So there's some things that we have to know ahead of time when we can even start telling the community that this is going to happen, and that includes our own community, the school, people on the outside, news, press releases, and everything else. We're going to have to figure out when we know the date and time of the contact, when we need to start the activities with the students, and when we let our ARIS technical mentor know if we intend to pursue a direct contact or a remote telebridge contact. Then there is a mentor that ARIS has. They're somewhere in the U.S. They select them. They don't keep the same person all the time. That you work with directly, that knows all the ins and outs about this this program. He's a ham, and if there's any questions, we've got his Skype address, we've got his telephone number, and we just constantly contact back and forth so there's no questions, and they help you right along. So we have 6 to 8 weeks we confirm our availability, 4 to 6 weeks we prepare our news releases, 3 to 4 weeks we prepare the student questions, 2 to 3 weeks out we submit the documents to the mentor, and 1 week, and just 1 week, we can finally confirm the contact time. And they say, well, all right, because there were some ambiguities with this particular space flight, and the Russians, and when the capsule was going to go up, and there was a change out, and they had some EVAs, the extravehicular activities, where the astronauts are doing their spacewalks for whatever scheduled programs they have. This really got moved around a lot. And even if you're using tracking software to figure out where this, the ISS is going to be in particular, on a particular day and time, that changes. So we're constantly updating that information, all right up to the day, right up to the very time we made the contact. That next morning we had to redo schedules because the information is somewhat ambiguous until we give a more clear time period of when it's going to come into view and when it's going to go back out. And then we make our contact, and then after the contact, we have to complete a NASA survey. And 1 to 3 days we submit an activity report, and then 2 weeks we submit video and any follow-up information back to NASA. And they use all this activity to correlate and make the program a little bit better. Okay.
Two quick questions.
Yeah, Tim.
How long does the pass last? How long does the contact? What's the maximum time?
They give us, what they end up giving us is several passes early on. And it's kind of funny because when it comes right down to it, they say, well, guess what? This is the only one you're going to have because of all these other things going on at the time. So we try to get a pass that is as much overhead as possible so we have the longest window of contact time in answer to your question. And these contacts typically run 10 minutes, 10 to 11 minutes, depending on how good your radio gear is, because you want to catch the ISS as it comes right up over the horizon until it's gone on the other side. And we, from experience, have learned that we can pick that ISS up when they're right on the horizon at about 1 degree. Frank's going to tell you, because he was the antenna operator for this particular event, we heard them when they were below the horizon because of tropospheric bending.
Are you going to be in a position to play this contact?
Yes, we are.
Here tonight?
Yes, you will hear it and watch it. Okay. So, okay, Frank.
Thanks.
So, direct connection to the ISS. It's going to pass over a venue at the time of the contact. It requires an amateur radio station at your location, and it provides an authentic hands-on experience to the hams. Right, Frank? Frank knows for sure. Education, of course, we talked about this. There's pre-activities to build momentum and interest prior to the radio contact. Post-contact activities to continue momentum and interest following the radio contact. We talk about the integration of radio technology into the curriculum. There's interdisciplinary activities, and we utilize NASA and the amateur radio educational resources. So the program's been around for a long time. It's well done. All the materials are there. You just have to make it work for your organization, and every organization is a little bit different. There's media involved. They encourage us to promote ARIS contacts with the media, advisories, press releases, other media outlets. NASA requested all non-NASA generated releases be run through NASA before it's released to the media, so we had to send them, all our press releases had to go to them for previous approval. And talent authorization, all parents and guardians and students had to sign a waiver if they were going to participate in this, because obviously it's televised and it's recorded and everything else, so they did have to sign waivers for that. And if VIPs are expected, question? Okay. If VIPs are expected, they want to know about this, particularly government officials. Okay, Frank. There's some talking points involved in this. I won't get involved in this in too much detail. Let's go to the next slide here. And there's a final survey, as I mentioned, that we fill out along with the ARIS activity report. Next slide. Okay, so that's the radio portion of it. I talked about the education portion at the beginning, and I talked about the radio portion. Now we're going to kind of meld these two pieces together, and let's see how this whole thing works. So this is a picture of some of the girls that are involved in these activities. They were, in this particular thing, building space shuttles and their own models. They actually had CAD software that they printed out. They could design a space shuttle, and then they could print them out and put them together. In this particular one, they were just doing glue. Other programs, they've built rockets in the past. So those are some of the other activities. Again, this was World in Motion theme. Next slide. Here's a picture of one of the students using a CAD program designing a space shuttle. They would go through this whole program as to all the different, they actually learned about the different parts of the shuttle, the propulsion systems, communication systems, everything was involved in this whole thing, along with things on how it's put in orbit, tracked. So they really kind of got into this knowing absolutely nothing, and left the program knowing quite a bit about the space program. And we have at RIT a 3D printer. Anybody familiar with 3D printers? Right, so those of you who aren't familiar, you can take the output of your CAD program and actually print objects and create objects. It's a special hard plastic. It's obviously molten when it's printed, but you can actually create solid objects on the fly with a printer. And you can see that each of the girls created their own space shuttle based on their own design from their own CAD work. We talked about some of the things about how we make communication with the ISS. We spoke about radio frequencies, a little bit about Doppler shift. We talked about azimuth and elevation, and obviously the best way to do that is to relate that to 360 degrees on a pie. We got them oriented with north, 0 degrees, 90 degrees, 180, 270. And we spoke about, to visualize it, when the pie is horizontally, to give them an idea, and we gave an orientation of north on the day of the contact in the auditorium where north was. I brought in an aero antenna, and we actually simulated the flight of where the ISS was going to be. Looking at north, we had the degrees, we had everything as to where this was going to be, and we turned the pie on the side, and we gave them an elevation, or gave them an idea of what elevation was, 0 degrees, 90 degrees, 180. And so they were able to actually visualize, before this happened, where the ISS would be passing over RIT. So it gave them a good concept of how that would happen. Next slide. So that's what led up to this. However, we have issues that we have to overcome on our end to make sure that this is going to happen. And right up front, the ARIS program requires 2 complete radio stations at each site that this happens at, okay? So we were lucky. Instead of bringing in all kinds of equipment, we couldn't really do that at Xerox Auditorium. RIT has 2 full-blown ham radio stations on opposite ends of campus. One is the K2GXT Club at the east end of campus, which is the club that's been there for decades. And on the west end of campus, we have a recently built, for Project Meteor, for launching balloons and other objects into low Earth orbit. We have our own high-end tracking station, and the call sign is W2RIT for that station, and RIT's traditional call sign, legacy station, is K2GXT. So we had to kind of get our equipment up to date and all in shape to make this happen. As you know, students come and go. This is during summer break, so a lot of the equipment was just not ready to roll until we put it all together. Plus, we had to have uninterruptible power supplies on both stations. And then we had to figure out how we're going to get all this audio back to Xerox Auditorium. So there's a lot of things that had to happen on this. And the primary station has to have tracking antennas. The International Space Station is relying on ground stations to make up for the power that they don't have on board, or the receive sensitivity they don't have on board. Okay, they're just running a little antenna on the outside of the ISS. And when this ISS comes up over the horizon, it's thousands of miles out. Okay, so you've got to make up for that gain on your end. So we have very high gain antennas with preamps running 100 watts into the antennas.
Jim,
and preamps.
how much watts are they actually pushing out?
The ISS, I couldn't tell you. I think it's around 10 watts, something like that. I'd say around 10 watts. I think it's about 10 watts. Remember, Pete, how much the ISS is running? What was that?
They had a D700 on board, if I remember correctly, 10 watts.
Yeah, at one time. I don't think they run at high power, though.
They're going high
I
power.
don't think so, no. So we made our calculations based on them running 10 watts. And we ran 100 watts on our end, plus we had received preamps. Next slide. And also the backup station, they only require us to have some type of Omni. We don't have to do the full-blown replication of the first station. So they're going to want to know ahead of time, and these questions that come to us very, very early on, because they won't even let us proceed with the program if we don't have all this gear in place and we can prove it. So they want to know who the coordinator is, they want cell phone numbers, home phones, all that information. Next slide. And then we have to send them the information about the station. They want to know what transceiver we're using. Does it have memories? How many? Are the memories tunable? Our power output, our frequency range, what are steps of the contact? Do we have a preamplifier? What's the brand if we do? Do we have a transmit amplifier? Is a radio capable of non-standard splits? What type of antenna do we have? Is it an azimuth elevation rotor? The manufacturer, the gain, number of elements, polarization. Do we have a satellite tracking program? What's the name of the software if we do? Do you have automatic antenna control? Do we have packet capability or slow scan TV? Do you have a phone patch? What brand of SWR bridge do you have? They want to know. All right? Let's face it, you got a piece of junk, you know. They don't know. I'm telling you, after talking to the mentor on this, it's amazing what some people have or think they have. So we really made to make sure we had our ducks in order on this. And what type of cable do you have going up to the antenna? We had 7/8 hardline. And then, this is all duplicated for the backup station. Of course, it could be a little bit different. Okay, now they also want to know if we have any antenna obstructions. So if there's a pass, and we have an obstruction, do we lose contact during a specific portion of that pass? And they have to know about it. Okay? So we fill that out and a duplicate. So, yeah, it's very involved. And this is going to be a little bit high-level overview of what's happening. We have the ISS that's orbiting at 17,000 miles an hour. It's extremely fast. It will cover pretty much from coast to coast in 10 minutes of the United States. And usually it's from the northwest portion of the United States to the southeast portion. So it is cruising. So you can imagine a Doppler shift that we have to contend with. And that's why we use automated tracking software that is constantly tracking that ISS within a couple of degrees and is changing the frequency of the radio as this is actually happening to compensate for that. And I'll show you how that works in a minute. So we have the ISS, and in the ISS is the module where this radio is, the ham radio portion is, right in there. And then we're able to communicate on 145.8, and anybody can do this. I've heard the ISS from my Jeep, and just going down the road during contacts, I can actually hear it during different school contacts. Obviously not so far out on the horizon when they're close overhead. I've actually listened to live contacts. And this is our W2RIT station on the west end of campus. And this was K2GXT. We had an Omni on the east end of campus. Everything that these two stations did was replicated identical. What was happening at one was happening at the other. So literally, if one station went out, we could just flip a switch and we're operating off the other station. And it should work without a hitch. And one more thing here. I will get to it later on. Go ahead. So now we have our tracking antennas up above our Omni, and this comes into our mission control at W2RIT. This is actually a photograph of inside of mission control. We have a couple monitors on the walls showing us a global view of where satellites are and a narrow view of what's happening. And we have some gear on one half of the station, and we have tracking radio. This is the IC910 that we use. There is rotor control with an automatic rotor control on top of that. And two operators can sit here, one operate the radio, and we actually move the rotor control over here for the rotor operator, and there's another monitor there. And this was also replicated downstairs at the K2GXT club room. We had two radio operators there that day, one monitoring the antenna situation and another operating the radio. The question is, how are we going to get all this stuff back over to Xerox Auditorium? That's the big question. So we wanted something, we wanted to obviously use a mode that there wasn't going to be really any audio delay, and we wanted something very reliable. We use a program on campus called Mumble, but it's very kludgy with regards to having our own server. You got to set it up, and it was just too much involved in that. So we use Skype. Skype is probably the most reliable program out there in the world. If you've ever used it and you've tested it, the delay is almost negligible. You're talking tenths of a millisecond as far as audio delay, and especially when we're now running from one end of campus to the other campus on gigabit Ethernet, almost no delay whatsoever. This is very, very reliable. So all we did was we loaded up Skype on this PC, ran the audio in from the radios, had Skype on this PC, loaded the audios into the radios. Each station had their own call sign, and we ran separate feeds to Xerox Auditorium, independent of one another. Next slide. So here's our W2RIT station. You can see operators there. And this was K2GXT, the backup station. And we had our IP audio going into the control room at Xerox Auditorium. And you'll see two laptops. And one was pulling audio, Skype audio from W2RIT. The other one was pulling audio from K2GXT. And everything was running in parallel. And we had, everything was mixed. There was audio mixing circuits. And it was feeding audio from the wireless mics in Xerox Auditorium and audio back to the speakers in Xerox Auditorium. Now, you talk about Murphy's Law, what's going to happen? A week prior to this, the entire control system for Xerox Auditorium crashed. Everything. The audio, video, everything went down. So there's a podium and there's smarts in there and there's a whole unit. They had to send this whole unit out for repair. Well, right behind where all this sets is a very large racks. It's really a long rack of equipment, AV equipment, projectors, switchers, everything. Well, I was fortunate this summer to have a student with me that we hired to do does a lot of my legwork. And I said, okay, let's rip this whole thing apart and let's bypass everything and let's feed everything directly from this soundboard directly into there. And we ended up bringing in audio, mixing it with the wireless mics, and we were able to provide audio to Xerox Auditorium, which they didn't have, and video feeds, all through just backdooring all these connections on the panel, and it actually happened. So it was probably fortuitous that that thing went down because we ended up with a better setup as if we just left Xerox's thing that just went by itself. Next slide, Frank. So in the front of Xerox Auditorium, we had 3 large screens, and the one on the left was showing Suni Williams. Talked a little bit about her. She was the 9th woman to walk in space. As of 2007, she holds the record for female space travelers, the longest space flight of 195 days. And she has a couple previous missions. And in addition to the one she did there, she also did a follow-up to this mission and was a commander. So she was very active, and she was very happy to be involved in this. And so you can see we brought an audio from the control room for the auditorium, and we even had 2 wireless mics because I had like anything, everything was redundant. So I had another one of these mics set up with a separate receiver back on the podium. So if that thing died, I would just grab the other one. Now, I'm paranoid, all right? If the whole control room crashed, all right, right under the shirt there is my iPhone, all running Skype, ready to go to talk to one of those 2 stations, either W2RIT or K2GXT directly. So this whole system went down, Xerox Auditorium crashed. All I had to do was whip out my iPhone, connect to one of those stations, and we still had connectivity to the ISS. So, third fail-safe system. Okay, Frank, next slide. This is a little block diagram. You probably can't see it very well, but you can see the redundancy. In Xerox, we had a primary and secondary microphone. They fed the mixer. We brought audio back into the room amplifier at Xerox Auditorium. Then we brought also audio back to a switch box into some USB interfaces that were external that fed both of these laptop PCs. And then that brought audio back and forth, one to K2GXT, the other one to W2RIT. And then we also brought video back because we had to have a way of, like I said, we had 3 large screens. We wanted to show something on the screen, so we're showing the tracking of the ISS. We had a live video feed from a webcam up at W2RIT, the mission control. We just saw the back of Frank's head the entire time. It was great. And then we had 3 projectors in Xerox that we fed directly from this video switch. We bypassed everything. Everything worked great. Next slide. So how do we make this all happen? Well, we had to have, I made up this checklist for each station as to what we had to do to get each station set up days prior to the event, and then we had a checklist for the morning event. And you can see, set up the ops on, we had a talk around channel, 446.00, it was a slightly different frequency, but we all had a handheld on a talk around channel, simplex, on campus, so we could all talk to each other outside of all the ham frequencies. And I had an HT on my belt, you'll probably see it in the audio, that was monitoring this local channel. So if somebody had to give me cues and commands and things like that, and I could hear what was going on, that would happen. Then each station, primary station, had a separate VHF radio tuned to 2 frequencies. Those frequencies were uplink frequencies to the ISS, and I'll tell you why. They gave us, NASA said you have to have 2 frequencies available for this contact in case they had interference up on the ISS. So that was a last minute thing. You're going to be using channel 43 and 46 or whatever it was, all right? They have these channels, and then you have to figure out what the frequencies are. So now we have to program those frequencies into our radio, the 2 uplink frequencies and the downlink frequencies, and we have to program in memories with all the Doppler shifts for that whole 10-minute pass. And this was just a backup. So in case we lost the automated control from the rotor controlling the radio frequencies, the software, we could manually shift memory channels to keep track of the ISS as it came up, went overhead, and back down. And of course, that was a manual operation on the backup station because they didn't have a beam and everything was being done manually. We had to disable the UHF band on the radio, set the radio to full power, ensure that Ham Radio Deluxe from the PC can control the radio, ensure that audio from the PC is feeding the radio. So that was for the primary. We had to duplicate that back at K2GXT to make sure that happened also. And then the morning of the event, we set up the PC first from the SatTrack check. We had a separate checklist, this is one Frank was using, for the satellite tracking station. Set the radio to full power, ensure that HRD from the PC can control the radio and the frequency. We ran audio checks back to Xerox Auditorium to ensure that everything is working correctly. We had people in Xerox with microphones and everything, making sure this was just perfect, working perfectly. And we had to make sure we were monitoring the uplink audio, so we had somebody listening to make sure that we were actually transmitting back up to the ISS on a separate frequency. Next button. And this was a SatTrack station. This was what the Sat Tracker had to do. He had to log into the computer. He had a username and password. connected up to Skype, tested that with, we had the SAT person working on Skype because the radio person had to concentrate on working the radio. Launched Ham Radio Deluxe, ran that SAT track program, selected the frequencies. I had a checklist for everything that had to be done in that software to make sure that this thing was working, including powering up the rotor controller, all the way down to connecting with the rotor, everything that had to be done. Even if part of it was done ahead of time, we didn't trust anything, and we knew from experience that a day passes, a lot of this connectivity fails between the rotor and the radio, and you have to reestablish it. And then the morning of the event, same thing. Go through this whole checklist, make sure that everything was working. We could even operate the rotor manually if we had to. And we had to confirm on the rotor there's azimuth and elevation meters, and we wanted to confirm that with the software. Everything had to be done and working. And we also did we had to make sure that the radio operator was advising us on our talk channel, Capcom channel, of when the ISS was 5 degrees below the horizon, and at 0 degrees, and then 1 degree, so we would know that, hey, we should have some type of contact by now if nothing was happening. Okay, Frank, next one. So I ended up making up a chart, and these are some of the frequencies that, these are not the actual frequencies, these are fake frequencies because we can't disclose the uplink frequencies, but these are the actual downlink frequencies. So the pass was going to be from 9:31 to 9:42 a.m. And I had to end up making a chart for each of the two channels because the uplink frequencies were different. So we ended up having to luckily we ended up on the primary frequency they gave us, but if something happened, we would have had to go to the second frequency. All right, and then all these different channels change. So technically, there were 7 different frequencies that we were operating during the course of this pass. When it was directly overhead, we'd be on 145.8. However, as it was approaching us, it's obviously a positive Doppler shift, so we were having to tune high, okay? And then as it moved away from us, it's a negative Doppler shift, and we had to turn our radios low. The software did all this, but we had everything in memories also, so if everything just failed, the software failed, we could just manually operate the radio's memories, and we can manually operate the rotor controller. So everything worked out quite well. Next slide, Frank.
Jim, what was the modulation?
It's just FM. Just FM, straight FM. And we're doing all this on the ground, from the additional power to the preamp to changing frequencies, because the radio on the ISS doesn't do any of that. It's just a standard FM transceiver. So we have to make up for all these differences, the Doppler shift and everything on the ground. So this is an actual chart I made up, or a chart I made up of the actual location of the ISS every 30 seconds during that pass. And Frank was watching this thing like a hawk, and he was actually making sure that exact this minute that rotor was reading those exact readings. So at 9:31, when this was supposed to come up over the horizon, it was at 303 degrees azimuth at 0 elevation. And at 9:31 and 30 seconds, 304.5 degrees, 2 degrees elevation. And on and on and on and on until this thing got up overhead. So we had to make sure, and you can see here that when it was directly overhead, it was at 42 degrees azimuth, and the elevation was 62 degrees. So it never got quite up to 90 degrees, but it was up at 62 degrees. And you can see that when it came up over the horizon, it was 1,400 miles away from us. And as it got closer, by the time it reached its closest location, it was only 288 miles from us. And then as it receded, it got back down almost 1,400 miles away. But because of the gain that we had on our station, we were able to have full quieting signal the entire way, even as it started dropping over the horizon before it came up over the horizon. Next slide. So, that's in a nutshell. That's what happened. I'm going to have you watch a video, but you're going to see that I got shocked, kind of shocking, you see the look on my face, because typically I thought we'd be calling the ISS and they'd be responding. Well, we're just sitting there listening, and the ISS isn't even up over the horizon yet, and all of a sudden they're calling us. So whoa, and we thought maybe our time's off or something like that, but you could hear them fading in, and, there's NYSS calling. So, Frank, why don't you click on that little link up there called Watch Video Contact, and we'll listen to this. Yes. Make the full screen, would you? Full screen here.
Thanks for being here. This is really exciting. This is the first time that we've had such an event here at campus at RIT with an exclusive conversation with the International Space Station, as Jim talked about. A lot of work goes into preparing for this wonderful 10-minute conversation. And Jim and I partnered on this, so this is something that we put together between the Women in Engineering program at RIT and then the Amateur Radio Club here at RIT. And we also have a staff of folks that are working hard during this week as part of our camp, and we've also invited other camps to be here. So we have RoboCamp folks. Let's hear from you. Yay! Okay. Yeah. And we have Little Kids on Campus over here. Let's hear from you all. Yay! All right. And then we have the Women in Engineering Everyday Engineering Camp program. Let's hear from all of you. All right, great. So the format will be, we've solicited some questions from a wide variety of people. Some of the young ladies who sent in questions are having the opportunity to ask those questions that they submitted. And some of the young ladies that are asking questions are asking other questions that were submitted. So you might, if you send us a question, you might hear your question by one of these girls. So there's 11 students here, and they vary in grades 5 through, I think we have up to 8th grade asking the questions. And each one will ask one question, and then after you ask your question, you'll go back to the end of the line, and if we have time, you'll have a chance to ask your question number 2. Okay, girls? Got that? Miss Olivia is the one that's going to be directing you and helping you out and making sure that you're doing what you need to do. Okay, and we're going to be talking to Sunny Williams, is the astronaut. And any questions before we only have, I think, like probably 1 minute. How are we doing on timing?
NA1SS, we hear you. NA1SS from W2RIT, over. We're right on the horizon, so they may not hear us. Okay, calling NA1SS from W2RIT, over.
1 ISS has got you loud and clear. Help me.
Very good. Okay, good morning. Sonny, this is Jim on this end, and welcome to the Women in Engineering program at RIT, over.
Jim, we've got you loud and clear. We're happy to be with you, flying above you on the ISS.
Okay, let's start with our first question, Sonny.
Hi, my name is Haley. Do you crave things in space that you have on Earth but can't eat in space? Over.
Absolutely. One of the biggest things that I like on Earth that we can't really have up here is pizza. And because bread has a lot of crumbs and they fly all over the place, so we don't have a lot of bread. Instead, we have tortillas or little bite-sized breads up here instead. Over.
Hi, my name is Marina. How long did it take to build the ISS? Over.
The ISS probably took about 10 years. The first piece went up in 1998. First men who lived on the space station was in 2000. And right around 2010, we finished it to its 4 solar array configuration that we have now. Over.
Hi, my name is Ellen. What is the smallest thing on Earth that you can see with the telescope from the space station? Over.
Well, I'm not exactly sure of the smallest thing, but I was able to see the Statue of Liberty. I was assisted because it was nighttime, or getting to be nighttime, so there was big shadows, and that helped me find it. but something around the size of the Statue of Liberty is probably the smallest thing we can identify. Over.
Hi, my name is Maddie. How are hours and days different in space than on Earth? Over.
About 16 times a day, a 24-hour day, so our nights and days are about 45 minutes each. However, we try to stay on Greenwich Mean Time, and so we sleep about 8 hours and are awake working and eating and exercising about 16 hours of a day. We just use the lights inside to regulate the lights for day and night. Over.
Hi, my name is Hannah. If the ISS is designed to be in permanent orbit, are there adjustments that are made to maintain orbit, and how are they accomplished? Over.
Absolutely. You know, we are still in gravity's field, though it's microgravity, so we get pulled toward the Earth. So we have thrusters on some of the visiting vehicles that we have on the back of the spacecraft. An ATV, which is a European vehicle, or a Russian Progress, all have thrusters. And every now and then we need to do a reboost to increase our orbit. Over.
Hi, my name is Skylar. What do I need to study in school if I want to be an astronaut? Over.
We have astronauts who are doctors, engineers, scientists, pilots, so any of those fields are great, but the background to that is a little bit of science and math, and make sure you study hard at school and find something that you like to do, and you'll become good at that, and then you could bring that talent to the astronaut program. Over.
Hi, my name is Ayla. While you're in space, do you have any peculiar content in your dreams? Over.
Interesting you should ask that. This is my second time in space, and I keep dreaming about my dog at home. But when I am now on Earth, I sometimes dream about being in space, and I think you probably dream about things that you're familiar with. So we're lucky to be up here so we can dream about floating around. Over.
Hi, my name is Claire. Do astronauts get haircuts while at the ISS? If so, how? Over.
Some of us get haircuts up here, and if you're going to get your hair cut, you have to be careful because hair is going to get all over the place, and so you need to have the vacuum cleaner nearby so you can suck it all in. But, yeah, hair up here looks a little bit different than on Earth, of course. Over.
Okay, stand by, Sonny. We're going to switch antennas. This is W2RIT with the NA1SS. Switching to backup channel now. At this point, the beam had to swing all the way Okay, around. next question.
Just because of this particular
Hi,
pass.
my name is Molly. How do the astronauts know
We switched
when
over to the
wake up and
secondary
go to
station,
sleep?
but the switchover
Over.
didn't go so well. We went back.
Okay, we'll switch back to our primary channel. Over. Okay, next question.
Hi, my name is Chetta. What type of research are you doing? Over.
I think I stepped on you. Can you repeat your question? Over.
Repeat your question here?
Hi, my name is Chetta. What type of research are you doing? Over.
Oh, we're doing a lot of research on ourselves, for example, because we've got to find out what happens to humans being in space for a long period of time. We're also doing basic science, chemistry. I was actually doing some combustion experiments this afternoon. We're also, of course, working with the robotic arm to get ready to capture a vehicle. We have experiments going on outside and even at night in microgravity while we're sleeping so we don't disturb them. So all sorts of experiments up here. Over.
Hi, my name is Claire. Without gravity, when you exercise, do your muscles feel tired? And how does it differ from exercising on Earth? Over.
Absolutely. I just got up here and I didn't exercise for about 2 days, and as soon as I got on the treadmill, my muscles really hurt a lot. And speaking of the treadmill, you have to be held down by bungees, and so it's sort of squishing your back and making your legs pull you up, and that helps you to work out and increase your muscle mass. But yeah, it does hurt, and it's a little bit different than being on Earth, but you need to do it to maintain muscle and bone density. Over.
Hi, my name is Haley. Do you feel more nauseous or hungry in space than on Earth? Over.
You probably feel a little bit nauseous. This is my second time up here, so I didn't feel bad this time, but the first time I definitely felt nauseous, just as your body has to get used to floating around. You know, you don't really necessarily feel hungry at first because food is not sinking down like it does in your normal body on Earth, and so you just got to keep eating so you don't lose weight up here, because you could lose weight pretty easily. Over.
Hi, my name is Marina. What tools do the crew members on the ISS use to gather information? Over.
Well, we have a bunch of people on the ground in mission control in Houston and Moscow, in Japan, in Europe, that are all helping us to make sure that we know how the vehicle is working and to send us information. We have an IP phone so we can call home. We have a computer system so we can get information through telemetry and data up here as well. So there's lots of ways to communicate with people back at home and get information. Over.
Hi, my name is Ellen. What is different about boiling water when you're on the space station? Over.
That's an interesting question. I'm not really sure about that. When we're not in vacuum while we're inside of the space station, so I think boiling water is relatively the same while we're in here. But if you were in vacuum, for sure, it would be different. Over.
Hi, my name is Maddie. Do you stop aging when you're in space? Over.
I hope so, but I don't know if that's really true or not. I think we're spending just as much time aging as you guys are, unfortunately, but I wish I'd come back looking a little younger like you guys. Over.
Hi, my name is Hannah. How do you keep your food from floating away from you when you're eating? Over.
I'm right now, and I'm watching these guys, my friends, eat here, and we have some food in cans, and we have some duct tape that we put backwards on the table so you can keep the can down so it doesn't float away. Most of our food also has Velcro on it, so we can Velcro it to the wall. When we're drinking something, we have to have a stopper so the fluid doesn't just keep coming out, because it will just keep coming out and form a pretty ball. Over.
Hi, my name is Skylar. How many miles do the astronauts travel each day? Over.
Ooh, I should have done a little bit of math, because we go around the Earth 16 times a day, so maybe you guys can add that up here, or multiply that up yourselves, because I don't have the absolute answer right now. But a whole lot, I think. I jogged the other day for just a little while, and I went over 9,000 miles when I was jogging. Over.
Hi, my name is Aylis. Why do astronauts travel to space? Over.
Good question. Well, I think what we're trying to do is just like the explorers of the past, trying to reach out and find try to answer the next questions that are going to come up of how to keep our planet healthy and safe, try to understand our planet from this perspective, try to force creativity by people trying to understand and engineer new techniques that work up in space. It's easy on the ground to do that, but the new ideas come from new places and new things, and that's what we're doing up here. Over.
I think we have time for one more question, Sonny. Go ahead.
Hi, my name is Claire. What do you do for fun when you are not doing not doing space station work? Over.
Wonderful window called the cupola, so we take a lot of pictures of our planet and also of the atmosphere. We were taking pictures of the southern lights just the other day, as a matter of fact. We also have computers, so we listen to music, we watch movies, and we have some TV shows up here, not real time, and hopefully we'll watch the Olympics coming up. Over.
Okay, Sonny, we're about to lose signal. I have one quick question. What did it feel like to break the world record for women in space? Over.
Happenstance, and I think I just broke a record waiting for somebody else, one of you guys down there, to break my record. So I hope one of you guys will follow in my footsteps and be up here and be going maybe to the moon or over to Mars. Over.
Okay, thank you very much for the Women in Engineering at RIT. We'll catch you when you're back on the ground, Sonny. Thank you. So there you have it. What I didn't tell you is that...
Wasn't that exciting? That was awesome. Let's hear a round of applause to all the tech people that made this happen. Awesome. Let's hear it for these girls. They did a great job. Nice job, ladies. Go find a seat, okay? Go find a seat.
What I didn't tell you is that all those questions, there's 20 questions, they are prepared way ahead of time, and they're all approved by NASA, and they get sent up, and Sonny gets the questions well in advance, a week in advance, by email, so she can prepare her answers for some of the really tough ones, of course. But
Who's the woman that speaks?
that is our director of the Women in Engineering, and she runs the whole program. She's been there for a couple of years now. As one of the gentlemen just stopped me, and he said he was in the 1961 was the first woman that went through engineering program at RIT, and just one of them. So they've come a long way. The program is successful we have more and more women, especially even in electrical engineering. Believe it or not, the women tend to gravitate more towards electromagnetics and fields program. A lot of them end up working at Harris, a lot of different other programs. Do a lot of microwave design, antenna design, fields, things like that. A lot of research. There's a lot of grads in it, having to do with interocular transplants of devices that they can read with radio frequencies, and we have entire libraries of modeling of the human body and the tissue and their characteristics in RF fields. So they can do a lot of work in the medical area also with that.
Jim, just a quick question. Would there be a website that you could watch that at?
It's on YouTube.
It's on YouTube?
Yep. Just do a search for Women in Engineering RIT, or ARIS RIT.
Rara Reg had a link to
Yes.
the Henrietta newspaper, and they had a link to the video.
Yep. Yeah, there's a lot of activity. So I'm here obviously to push the program a little bit too. If you have any children, grandchildren, women that'd be interested in attending the camp, it's very interesting. They start them out early, they get them exposed early, they get a lot of activity. And go to the next slide, Frank, and I'm just show you one 30-second video. It's up on the top. And to give you an example of the impact that the program has on the kids.
Yeah, some questions.
Yeah, it was really actually cool. It was cooler than, well, anything I've ever done in my life.
That's wonderful.
Tell me a little bit about what's going on here today.
Probably hearing her answer, knowing that she's not on the Earth, and the Earth is pretty big. Most people are on Earth.
What questions did you ask?
I asked her if she craved anything that she could have on Earth, but she couldn't have in the space station. And she said pizza, because they can't really have very much bread. So it's hard to get pizza out there.
So the kids really got a lot out of the program. And if we go back to the last slide, that is our follow-up. We have to do a full report. It's only 2 pages of a 5-page report that we have to submit to NASA. On the program, the impact, who was covered, how many participants were in there, accolades, links to the media, web links, everything that you can click on. And all this is available at the Women in Engineering website, we at RIT. And I think that's it. Next slide, Frank. I think that's it. So any questions at all, or question?
What were you saying, you had to change the antenna?
Well, like any other rotor, you can only do one full 360-degree sweep, or you're going to wipe the cable out. So, so it has to stop at some point. Well, the way this was tracking just happened to be going past our stop point, so the antennas had to swing all the way back around and catch it back in the backside. So that's what the little loss was. Question, Becker?
What was the specific date you made this contact?
I think it was the beginning. It was July 23rd, I think, of this past year. It was at the beginning. It was at the top of the slide there. Question over here, Pete?
Yeah, I was up in Saranac Lake, and I heard it with the downlink from my handheld.
Yep.
And we also watched the RIT website.
Yeah, we had a live feed. We had a live stream also. Yeah.
There's a time difference between what we heard real from the space station and on your website.
Sure.
I'm curious. It's a wonderful pass. What was the elevation, the maximum elevation?
42 degrees. Or no, 62. It was 62 degrees? 62 degrees. 62 degrees. So, question?
Yeah, not actually a question, but some information on that. I was involved with StarX back in 90.
Oh, yeah.
When Dr. Garrett was one of the...
Sure, Owen Garriott. Yep.
Well, I was kind of surprised how they ran that. He held actually a 5-watt on a 2-watt handheld. And the antenna was a wire that was inside the shuttle bay door with duct tape.
Yep. It's amazing. The ISS does run their station in repeater mode, crossband mode, VHF, UHF. And I have an audio tape, or audio clip, I didn't bring it, but I was standing out in front of RIT with just an HT, and I had my PC in my office tuning a receiver in Boston. And I said, see if I can do this. And just outside RIT, obviously when the ISS got fairly close overhead, I was operating through the crossband repeater and made a couple contacts just off the HT in the parking lot. And I heard myself full quieting in Boston, on the downlink, so I know it works quite well. Another question?
Now that you got all the station stuff set up, all the, everything spruced up and all that for ISIS contacts, are there plans to maybe do this again in the future, or maybe it be a...
Yeah, I think we're gonna apply again. Unfortunately, the window just closed. They didn't want to do it this year because it's a different theme, but when they come back around to this theme, they will reinitiate it for another contact. And of course, a lot of the work is done. Bill?
Jim, how many man hours went into this for this time?
I lost count. After the hundreds, I lost count.
Okay.
It
was quite an undertaking.
Yep. So.
Can one actually see the show?
At night you can, yep. Yeah, there's a lot of programs you can download. There's a zillion of them for your smartphone or whatever, and you just go out, watch this thing as it comes up. It says it's going to come up, you look, and there it is. And it really cruises. I mean, you'll see it. You'll know it's the ISS. And some nights it's actually brighter depending on where it is. Yep. Frank, do you have any comments about your experience and all the sweat that rolled off you left on the seat when you got up?
That wasn't sweat. No, it was actually great fun. Thanks for asking me to participate. Working with the guys at RIT and everybody that put that together. Such an impressive group of youngsters. And, making the contact with the ISS was very exciting.
Yeah, it was a lot of fun. Nobody here from RIT because RIT's on break. Everybody's home. So that's why nobody's here tonight. And what's happening in the club, we had a question, what's happening with RIT during the onset of the program. We're now working on, students have those little, you can get it for I think $10. It's a USB direct broadcast TV, DVB-T. It's a European standard for digital television. And I don't even think it's wide HD, it's just standard. And it's a USB receiver module, a little MCX antenna connector on it, and you can run them as a spectrum analyzer. And you can, out of the box, I think they do, I want to say 100 megahertz to 1.3 gigahertz as a spectrum analyzer, but they put a little low pass filter on them and a down converter to 50 megahertz IF or something. I don't know what they do, and then they've got them. They're using for the whole HF spectrum. And you can see 3 megahertz windows at a time, and you have a spectrum analyzer in the HF bands. It's pretty cool stuff, especially for $10. Kids are always doing something. One more question?
Jim, did you ever get to see the station in Houston that they built for
There is a ham station in Johnson Space Center. I haven't seen it. Jody Carville, who's the woman who was running the program, did eventually go down to the Space Center this past fall while she was down there for an educators program. Stopped in to see their activities there, so she got a first-hand look of everything that was there. But yeah, if you have any kids, grandkids that are, I think it starts at age, I want to say 4th grade and on up. We actually, believe it or not, on campus there's a daycare center for the employees called Margaret's House. We brought those kids over too, so they got an experience at 3 years old for what happened. So you got to start them early and get them interested. But they were just mesmerized. It was a lot of fun. I got paid to do it too.
Jim, thank you.
Doesn't hurt either.
No.
How about that? Jim, thank you very much. Very well done. We're very proud of RIT and your efforts. Hey, that wraps up our program for this evening.